Hello and welcome back to ISOmath. Today we're going to talk about composition of functions. Alright, here we go. Review of some composition of functions. First of all, let's review some functions. Remember when we asked to evaluate the following, f of x equals 2x squared minus 3, and here we're asked to find the value of f of 3. Remember, that's nothing more than what I'm doing is basically here's my value of 3. Wherever I see an x value, I'm going to input the value of 3. And solve from there. So that's essentially what that's asking for. And when I do that, I equate it to 3 squared minus 3, which obviously comes out to 2 times 9 minus 3, or 18 minus 3, and 15. When we're asked what's the domain of f of x, well, in this case f of x is a polynomial, and a polynomial function, and they exist everywhere. The domain of a polynomial function is essentially all real numbers. So however, that changes when I have a rational function. Again, when I'm asked to find the rational function here, I'm basically going to take that one value, and wherever I see an x, I'm going to plug in that value of 1, and I'm going to solve for my equation. So again, this should be a review for most of us. If not, you can go back to previous lessons to get that together. So when I go through there, I end up with a negative 1 over negative 1, or simply a value of 1. However, when I'm asked to find the domain in this case, you can see that because I have a rational function, I now have a place where this function may not exist, and that happens when I end up with the value of 0 in the denominator. And if you remember, what we used to do is take that x minus 2, set it equal to 0, that denominator set it equal to 0, and solve, and that is basically where the x cannot take on that value because that gives me 0 in the denominator. So this particular example, the domain of the function of f of x is all real numbers with the exception of x cannot equal 2. So if I take this even further, I remember I can easily input the value of 1/2. I can input any value. I can input any value into f of x, and that simply means I take whatever value is in there, whatever input value that I'm asked to substitute in, and I substitute it in wherever I see an x. That's what I'm asked to do. That's what it's asking for me to do. So when I do that, yes, f of 1/2, yeah, it gets a little complicated, but it's something we can handle. We end up being 2 times 1/4, because 1/2 squared is 1/4, and going through there and get my nice little fractions all together, and I end up with 5/2 over 3/2, which remember is nothing more than 5/3. In this case, what's the domain? Well, it's the same idea. It's with the denominator in this case equals 0, and so the domain is all real numbers, but x cannot equal 2. Or I'm sorry, yeah, x cannot equal 2. That's actually a misprint. This should be 2. And then we get into what's called composition of functions. Here I'm given a function of f of x, which is the 2x squared minus 3, and I'm given a g of x, which has a value of 3x. And here I'm asked to say, this is saying find the composition of g, find the f composition of g when it has a input value of 2. Some of us are more familiar with in this notation, which is f of g of 2. So essentially, different notations, they both mean the same thing. But what I'm asked for is basically, what you're asking for in this case is this g, the input value of g. So this is g of 2. So obviously 3 times 2, that takes on a value of 6. So I always work from the inside out. So that's my first value. So this essentially becomes, this is going to end up becoming f of 6, because after I evaluate g of 2, which gives me a value of 6, I then take that 6 and I evaluate that 6 on the f of x, and I input that 6 into that function, which essentially gives me my 2 times my 6 squared minus 3, and I go through solving that way. So when you have a compositions of functions, you always work from the inside out. Work from the inside out is what we're doing. So obviously when we, like I said, we first find the g of x value takes on the value of 6, and then I input that 6 into the f function, which obviously gives me 72 minus 3, or 69. What is the domain of this f of g of x? Because they're both polynomial functions, and they're both basically, there's no place where they don't exist. They exist all real numbers for g of x and all real numbers for f of x. You always start from the inside though. What is the value of g of x? You always start from the inside. What is the domain of g of x? It's all real numbers. What is the domain of f of x? All real numbers. So altogether, it's going to be all real numbers. Then I get into composition of functions. Again, it's the same thing. I'm doing f of g with respect to 2 in this case, or simply f of g of 2, I'm going to do the same thing as I did. Just going to basically, I'm going to take this 2 value and I'm going to find g of 2 first, and wherever I see that 2 or that x, I'm going to plug that 2 in for that x. So that comes out looking like my first. So always work from the inside, find my g of 2. So I plug that into that. You can see my g of x function right in here. Plug in 2, and that gives me f. When I equate that out, that gives me a 4 over 2 minus 1, which is 4 over 1, or 4. And then I take that 4 and I input it into my f of x function. So that's going to look like 1 over 4 plus 2, which is nothing more than 1/6. So even though I have rational functions, I treat it the same way. I first start from the inside out. I'm going to input my 2 into my g of x, and then find that value, and then input that value into my f of x. So now the difference here is now I'm asking for the domain of g of x, or I'm sorry, domain of f of g of x. Well, individually, I know the domain of g of x cannot contain the value of x equals 1, and individually the f of x cannot take on the value of negative 2. However, when I do a composition of functions, that's not just the case. It would be great if I could just say these are my 2 exclusions of the domain, but that's not the case. It is the case for g of x. You always start from the inside out. So because the inside piece here is g of x cannot take on a value of 1. So 1 is a no-no in the domain. So that's going to be one of my values that I cannot contain. But this is not necessarily true with my 2, because it's going to got to work a little magic. Why? Because it says x cannot, or any x not in the domain of g must be excluded. So that is all that means. So that statement is g of x, wherever g of x is undefined, that value cannot be in the domain. So that's cool. However, this one says any x value for which g of x is not in the domain of f must be excluded. What does that mean? That means that this input value here, or this, after I equate this out, it cannot take on the value of, in this particular case, negative 2. Meaning my g of x, the output of g of x, cannot equal negative 2, because if it does, then f of x blows up in this particular case. But understand that means g of x cannot take on a value of negative 2. So that's what I need to find out. So essentially that's what that's saying, is this x cannot equal negative 1, or 1 for the beginning, and the output of g of x cannot equal negative 2. How do I find that? What I do is I work a little magic. So since I know 1 is in there, but I got to find where g of x takes on the value of negative 2. So I take my g of x function and I set it equal to negative 2, because that's the value that f of x cannot take on. And then I go through my basic algebra, multiply both sides by x minus 1, and that gives me to that, and I get to negative 2x plus 2 equals 4, and lo and behold, I get a value of negative 1. So what does that mean? Well, that means that my domain is all real numbers, but x cannot be 1 and x cannot be negative 1, because when I input negative 1 into g of x, it spits back the value of negative 2, and negative 2 blows up this f of x. So those are my domain values that I must exclude. So, and when I go through compositional functions in terms of finding them in terms of one another without a specific input value, this is the same thing. Again, my input value in this particular case is when I'm trying to find f of g of x. Well, g of x has this value, f of 4 minus 1. And now what I end up doing is I'm going to take that as my new input value for my f of x. So I take that value and I input it wherever I see an x for my f of x. So this input value, boom, gets slid right into there. So I end up with 1. Well, so that basically, again, remind you guys, that input value is pushed right into that x value, and that's how I end up with this equation right there. And yes, then I got to go through some simplification. And again, to simplify, the way I get rid of that fraction right here is I multiply by the quantity x minus 1, x minus 1, whatever's in this denominator here, whatever's in this little mini denominator here, I got to multiply the top and bottom by it, because remember, this is nothing more than a fancy form of 1, and when I do that, I end up with the good old equation here, and I go through and I get my again, mathematically I end up with x minus 1 over 2 plus 2x, or I can simplify it down to here. So bottom line is whatever's in this denominator, that mini denominator there, that's what you're going to multiply by in order to get rid of that fraction, because now I'm able to get, I don't have a complex fraction anymore. I got a nice just regular fraction that I can deal with. And last but not least, you're going to be asked in this section to evaluate the expression using the graph below. Sometimes in your homework you're going to be asked to find out g of f of negative 1. Well, the trick is, remember that this is nothing more than g of f of negative 1. So I got to first locate my f graph. And my f graph obviously is this line right here. Here's my f graph, and there's my g graph up here. So my f graph, it says f of negative 1. So I got to first find the value of f of negative 1. Well, I go to negative 1. My input value of negative 1 is there, and I go up, and it has that point. So f of negative 1 has the value of a positive 1, because that's what the output tells me right there. That's what the output tells me right there. So this now becomes g of 1, because that's, I'm working from my inside out. Well, g of 1, so I look on my g graph. Here's my g graph. I input value of 1, I go up to 1, and it's that point right there. So g of 1 has the value of 4. So in this particular case, g of f of negative 1 has the value of 4. So my final answer will be 4. So this answer is 4. And that's how you evaluate graphs. Just basically go to input, and whatever the input is the other one, and that's how we go through that. I hope this has helped, and remember, check back to ISOmath for all your math needs. We'll see you soon.